For today's lecture, we're going to start talking about triple integrals, integrals over regions inside three-dimensional space instead of one-dimensional or two-dimensional. And so, just like before, we have some region that we're integrating over, now inside three-dimensional space. We have some function that we're integrating, now made out of three variables instead of one or two. And we have this symbol here, which means with respect to volume, dEV. That's how we write a triple integral. And what the triple integral does is, just like before, it calculates some kind of total mass. If we think of the function f of x, y, and z as measuring some kind of mass density or some kind of concentration of something at each point in space, and it varies in some nice way, then we use a triple integral to total that up and find the total concentration or the total amount of this. Mechanically, we do them the same as double integrals. We work from inside to out. We do the innermost first, the next, by doing three integrals in a row. The main difference with double integrals, and especially the single integrals at the bounds of integration, are going to be more work. And we'll talk about that in a little bit. So, for example, if we take the triple integral of 1 over a region R, that calculates the total volume of that region, like so. Or if instead it measures the density of some substance at each position, as I was saying, then the total mass is going to be the triple integral of the function that measures density. Mechanically, it's exactly the same, still inside to out. We can still also change the order of integration, just like we can with double integrals, although now there are a lot more choices. Do I do x, y, z first? Do I do x, then y, then z? Do I do y, then x, then z? Do I do z first? Any of these possibilities is something that we can do when doing a triple integral. The main thing that is going to create difficulties for you, and I cannot emphasize this enough, is that finding regions of integration and setting up the bounds for a triple integral is going to be a lot more difficult because it requires you to understand the geometry of the region you're integrating over. There aren't as many tricks. There aren't as many kind of easy cases as there are with double integrals or single integrals. We're going to need to get used to this, and so we're going to be spending actually a fair bit of time in these lectures talking about how exactly we set up the triple integral's bounds of integration.